power factor. The cosine of angle between voltage and current is known as power factor. According to the power triangle, on the base of the triangle there would be active power denoted by P, and it is defined as the average power in a circuit is known as active power, or the rate of producing, transferring and using electrical energy. It is measured in watts and may be represented in kilowatt, kW, megawatt, MW. On the perpendicular of the triangle there would be reactive power that is denoted by Q and defined as the power which supplies stored energy in reactive element of a circuit. It is measured in volt ampere but reactive, that is VAR, and may be represented by kVAR, kilovolt ampere reactive, and MVAR, megavolt ampere reactive. And on the hypotenuse of the power triangle there would be apparent power that is denoted by F, and is defined as the combination of active and reactive power, often defined as the vectorical sum of active and reactive power. The product of voltage in volts and current in ampere is also known as the apparent power. That is why it is measured in VA only. A measurement of transformer is done in kVA, that is kilovolt ampere, as well as the transmission line is also measured in the kVA, that is kilovolt ampere. Power factor is nothing but it is the trigonometric ratio cos of phi. So cos of phi is equals to base over hypotenuse. What is the base of the power triangle? That is real power, true power or active power denoted by P, and the hypotenuse of the power triangle is apparent power denoted by S. So from this definition can be the ratio between active power and the apparent power is also known to be the power factor. There are three conditions of power factor: lagging power factor, leading power factor, unity power factor. Now coming to the very first, that is lagging power factor. When the connected load is inductive, the angle between voltage and current will increase, that causes the decrement in the power factor. Whenever the connected load is inductive and the power factor is 0.8, it means the power factor is 0.8 lagging or 80% lagging. Whenever the inductive load is connected, we know that inductor opposes the change in current, that's why current will decrease and voltage will increase. So I lags behind the voltage by 90 degree. So whenever the waveform are there, so the waveform of current will lag the waveform of voltage by 90 degree. That is why we call it as the lagging power factor. Now coming to the leading power factor, whenever the connected load is capacitive, the work of the capacitor is to decrease the voltage or decrease the change in voltage or oppose the change in voltage. That's why voltage will be decreased and current will be increased. So that is why I leads, that is current I leads behind the voltage by 90 degree. The waveform of current will lead the waveform of voltage by 90 degree. So that is why we call it a leading power factor. Now coming to the unity power factor, whenever the connected load is resistive, that is the angle between voltage and current will be 0 degree, because the voltage and current waveform are in phase with each other. So we know that when the angle between voltage and current becomes 0 degree, so cos of 0 will be equals to 1. It means that whenever the angle between voltage and current will increase, it will cause the decrement in the power factor, and these both cases will be in lagging power factor and leading power factor, that the angle between voltage and current be out of phase to each other. Causes of low power factor. If we know that most of the load connected in industries, factories as well as domestic is inductive, say for example refrigerators, washing machines, microwave oven in the domestic level, and in the industries induction motor, induction generators, windmill generators, arc furnaces, and in the electronic side, switch mode, power supplies, inverters, non-linear loads are over here. So that causes the low power factor. So there are mainly two causes of low power factor. Out of them, inductive load is the one cause of low power factor, and the second cause of low power factor is nothing but it the high harmonic content. It means that whenever there is no disturbance, there is a pure sine wave, means normal position. Under normal conditions, there will be pure sine wave, there will be no any disturbance, but whenever there is an increment of current or voltages, harmonics are over there, and harmonics are the sinusoidal voltages and current in which frequency is the integer multiplier of it. So high harmonic content creates the distortion in the voltage and current waveform that causes the decrement in the power factor. Now we know that in a DC circuit, power is nothing. It is equals to P is equal to VI, the product of voltage and current. But in the AC system, power is equals to the product of voltage into current with multiplication with the power factor. From this equation, we can see that the power factor is inversely proportional to current as well as the voltage whenever the power of the system is constant. So whenever current increases or voltage increases, it causes the decrement in the power factor. Whenever the connected load is inductive, it causes the increment in voltage, that causes the decrement in power factor. And when the connected load is capacitive, it causes the increment in the we can say current and decrement in the voltage, that causes the decrement in the power factor of the system. Power factor correction. There are mainly three methods to correct the power factor. And the main cause to correct the power factor, because whenever the power factor of the load decreases, it causes the decrement to the appliances. The cost of the system will be high. So if we want to save the electrical bills and so many other costs, save investmental costs, running costs, so we have to increase the power factor of the load so that electrical bills can be managed at a time. Now coming to the methods how to correct the power factor, that is we are going to define by one. That is number one, static capacitor. On number two, there would be synchronous condenser, and on the third, there would be phase advancer. These three methods are used to increase the power factor of the system with their advantages and disadvantages to improve the power factor.